In 1977, NASA launched one of the most ambitious space exploration missions in human history with the Voyagers, two spacecraft named Voyager 1 and Voyager 2. These twin probes embarked on a groundbreaking journey to explore the farthest reaches of our solar system, eventually venturing into the vast, mysterious domain of interstellar space. Built with the most advanced technology of their time, the Voyagers were designed to investigate the outer planets and provide unparalleled insights into the nature of our cosmic neighborhood. Their mission was monumental, not only in scope but also in significance, aiming to expand the boundaries of human knowledge and imagination. Equipped with a suite of scientific instruments and cameras, the spacecraft set off on what became known as the Grand Tour. This rare planetary alignment allowed a slingshot trajectory past Jupiter, Saturn, Uranus, and Neptune, using gravitational assists as they sailed through the solar system. The Voyagers transmitted breathtaking images and invaluable data that reshaped our understanding of planetary science. They revealed the fierce and complex storms raging on Jupiter, captured the intricate and ever-shifting rings of Saturn, and provided the first close-up views of the icy, enigmatic worlds of Uranus and Neptune. These spacecraft became humanity's eyes in the cosmos, offering vivid portraits of distant realms that were once only imagined. However, the Voyager mission was not just a scientific endeavor. It was also a deeply human one. Each spacecraft carried a golden record, a time capsule meant for any intelligent extraterrestrial life that might one day encounter it. The golden record contained the sounds, music, and images of Earth, symbolizing a gesture of peace and an introduction to humanity. It included greetings in 55 languages, the laughter of a child, the roar of a rocket, and even the sound of a mother's heartbeat. This was a representation of life on Earth, capturing its diversity and humanity's yearning to connect with the unknown. In this way, the Voyagers were not just mechanical emissaries. They carried humanity's voice across the void, hoping that someone or something might be listening. Voyager 1, taking the lead, became the first to fly by Jupiter in 1979. It captured iconic images of the planet's colossal Great Red Spot and discovered volcanic activity on Io, the first such observation beyond Earth. A year later, it soared past Saturn, offering stunning views of its complex ring system and the mysterious atmosphere of Titan, its largest moon. Voyager 1 continued its trajectory out of the plane of the solar system, heading toward interstellar space. Voyager 2, traveling on a slightly slower path, benefited from the data collected by its predecessor. When it reached Saturn in 1981, its instruments focused on the planet's intricacies, revealing that Saturn's rings were dynamic systems filled with braids, kinks, and icy particles, sparking new theories about ring formation and planetary evolution. In 1986, Voyager 2 became the first spacecraft to reach Uranus, a planet shrouded in mystery. It revealed a pale blue orb tilted at an extreme angle, spinning almost sideways in its orbit. The spacecraft discovered 2 new rings and 11 previously unknown moons, offering the first close-up views of this ice giant. It recorded shockingly cold temperatures of -353 degrees Fahrenheit and detected a massive plasmoid in Uranus's magnetosphere, providing vital insights into its magnetic field. In 1989, Voyager 2 reached Neptune, the final planet of its grand tour, becoming the only spacecraft to visit the distant ice giant. It observed fierce storms and wind speeds of up to 1,200 miles per hour, the fastest in the solar system, and captured images of Triton, Neptune's largest moon, which revealed geysers erupting nitrogen into space and a landscape that may hide a subsurface ocean. These findings sparked continued interest in ice-covered moons throughout the cosmos, offering tantalizing clues about the potential for life in the coldest corners of our solar system. One of the most iconic contributions of the Voyager mission came in 1990 when Voyager 1, venturing beyond the known reaches of the solar system, turned its camera back toward Earth and took an image from over 4 billion miles away. This famous pale blue photograph showed Earth as a tiny speck, just 0.12 pixels in size, suspended in a sunbeam amid the vast emptiness of space. This single image became a profound symbol of our place in the universe, emphasizing our fragility and the shared responsibility we hold for our planet. Astronomer Carl Sagan reflected on how this image encapsulated all of human history: joy, suffering, and everything in between, contained on a single mote of dust floating in a sunbeam. His words immortalized the photograph, cementing the Voyager mission's role not only in science but in the cultural consciousness of humanity. As the years passed, the Voyagers continued their journey farther than anyone could have anticipated. In 2012, Voyager 1 became the first human-made object to cross the heliopause, the boundary where the sun's influence wanes and interstellar space begins. Voyager 2 followed in 2018, becoming the second spacecraft to enter this unexplored region. Even in the cold emptiness between stars, the Voyagers continued their mission. One of the most remarkable discoveries came from Voyager 1's plasma wave instrument, which detected a faint, constant hum from interstellar plasma. This marked the first continuous measurement of plasma density in interstellar space, providing new insights into the environment between solar systems. Voyager 2, now over 14 billion miles from Earth, continued to send back data, revealing that even the most remote parts of the galaxy are filled with subtle activity. Its sensors detected variations in plasma waves and cosmic radiation, suggesting that interstellar space is not static, but dynamic and ever-changing. These discoveries challenged previous assumptions and opened new avenues of research into the behavior of the interstellar medium. Keeping the Voyagers operational at such vast distances has been a feat of engineering and determination. With power levels lower than a standard household light bulb, the mission team has had to make difficult decisions about which instruments to keep running and which systems to shut down. Yet, through careful planning and creativity, the mission has endured. Every signal received from the Voyagers is a triumph, a fragile echo of human ingenuity and perseverance. Each piece of data contributes to our expanding knowledge of the universe, proving that even decades-old technology, when well-crafted, can achieve the extraordinary. The legacy of Voyager extends beyond science. The data it collected inspired the development of modern telescopes and future space missions. Its exploration of icy moons like Europa and Triton influenced decisions to pursue missions that search for life in subsurface oceans. Its observations of magnetic fields, cosmic rays, and plasma density have helped refine models used to understand both planetary environments and the broader galactic ecosystem. The Voyager mission also laid the foundation for the study of exoplanets, boosting humanity's dream of discovering habitable worlds beyond our own. Though their primary mission has long since concluded, the Voyagers continue to transmit some of the most poignant and awe-inspiring images ever captured. Their cameras have been turned off, but earlier transmissions revealed haunting vistas. The edge of the solar system, the faint light of distant stars, and the endless night of interstellar space. These final gifts remind us not only of how far we've come, but how much further we still have to go. As their power dwindles, a silent end is near. One day, the Voyagers will fall silent, drifting relics in the galactic sea. But their journey will not truly end. For billions of years, they will continue their voyage, silent ambassadors of Earth, gliding between the stars. They may never be found, and their golden records may never be heard, but their existence affirms that humanity once dared to dream beyond its grasp. The golden records carried by the Voyagers remain one of the most profound artifacts ever launched into space. Encased in aluminum and gold-plated copper, they contain greetings from Earth in 55 languages, selections of world music, images of life on our planet, and encoded scientific data. These records serve as a testament to humanity's desire to connect, to be seen, to be known. They remind us that we are one species, sharing one fragile world, and that our curiosity and creativity define who we are. Voyager 2, now coasting deeper into the unknown, remains an enduring symbol of this identity. It embodies the spirit of exploration that has driven humans to sail across oceans, climb mountains, and reach for the stars. Voyager 2's instruments, though aging, continue to gather information about the environment between the stars, contributing to our understanding of the cosmos. Even though signals now take more than 18 hours to reach Earth, each transmission represents a feat of perseverance and precision. Voyager's story is not just one of machinery and numbers but of human passion. The engineers who built it, the scientists who guide it, and the dreamers who see it as a mirror of our aspirations. Over 4 decades since its launch, Voyager 2 continues to shape our view of the universe and our place within it. It challenges us to look beyond our immediate surroundings and imagine what lies ahead. As Voyager 2 sails into eternity, it leaves behind a legacy of knowledge, inspiration, and unity. It tells a story not just of exploration but of connection between people, ideas, and the Earth and the stars. Though the spacecraft may one day fall silent, its influence will echo through time, a quiet yet powerful affirmation of humanity's place in the cosmos. Voyager 2 reminds us that we are capable of greatness, of looking outward in awe and inward with understanding. Its voyage is a testament to what we can achieve when we dare to dream, to ask what lies beyond, and to keep pushing even when the night is long and the destination unknown. The mission that began with a fiery launch into the Florida sky has become a story of endurance, wonder, and the boundless curiosity that drives us all. Voyager 2 is more than just a spacecraft. It is a message, a mirror, and a legacy, drifting ever onward through the stars. Its journey is not just a narrative of machinery drifting through the void, but a living chronicle of humanity's resilience, innovation, and ability to transform ambition into reality. As Voyager 2 continues its silent arcade through interstellar space, it carries with it the triumphs and hopes of generations who dared to believe that something crafted by human hands could survive and remain purposeful far beyond its original design. Over the years, as Earth's technology advanced exponentially, the aging Voyagers became both a marvel and a paradox. Primitive by today's standards, yet still more capable than many systems created since, simply because they were built with enduring craftsmanship and unshakable intent. Mission engineers at NASA's Jet Propulsion Laboratory have become the custodians of legacy hardware, keeping alive knowledge of now archaic languages, software systems, and radio techniques required to maintain communication with these distant emissaries. It's said that no mission in NASA's history has demanded such a long and personal relationship between its creators and the spacecraft. Engineers often pass down their knowledge like an oral tradition, bridging generations of problem solvers connected by a shared purpose, to keep the Voyagers alive for as long as physics and power would allow. As the spacecraft travel farther from the sun, the signals they send